LLMs are very smart and they're very good at being like, okay, this is like the type of things that you might want to unit test. But like everyone's data is super weird. And like most of the things that are super weird about that live in the heads of the people that have been burned by it a billion times.
The LLMs are really probably quite good at building descriptions. When we're thinking about tests for data, how does it know what the most important parts are to test?
It will be able to get you a very good first pass of the data hygiene thing. The wordy parts that are like specific about my business, it's like not going to be able to do those just straight out of the box. But what it will be able to do is work with you to, if you describe a unit test, particularly if it has good context about what the underlying columns are, what the data types are, what's expected. The interesting thing about data engineering is everything from software engineering applies, and then there's kind of like slight tweaks that make it different. So everything that your previous guests have said about how AI is going to affect software engineering, that is all relevant to data engineers. But the difference is
Hi there, and welcome to another episode of the AI Native Dev. My name's Simon Maple, your host for today. And today we're going to be talking about all things data engineering with Mr. Jason Ganz here, who works in the developer experience space for a company called DBT. Jason, welcome. How are you doing?
Hi, Simon. I'm doing great. Super excited to be here with you today. Big fan of your show, and excited to nerd out with you about data, AI, MCP. Who knows where it could go?
So, Jason, you're in the developer experience space. What does that mean?
Yeah, so DBT Labs is a company that makes DBT, which is a very, very popular way for data engineers, analytics engineers, and analysts to work with their structured data. Particularly in the past, you do ETL. We now live in an ELT world where you extract, load, and transform. And so organizations have just a tremendous amount of data these days. You have all of the records that are generated by your payment vendors, by your marketing campaigns, whatever you can imagine. Every business is just constantly spitting off just tremendous amounts of data. And you want to do things with that data, but also going from kind of the raw data that you have there to something that is useful and interesting is actually a very non-trivial challenge. You have to take that data and then you have to go and say, okay, I have all this data, but what is useful? What are the useful bits and context that I have here? And then you build it up, you apply transformations, you join it together, and you have to do that in a way that is flexible. So you make sure that you can connect together the different things. It's trustworthy so that you know that you're generating accurate data, and that it's not just accurate, but it's accurate and timely, that you're not kind of like blowing up the spend. You accidentally join two tables together, and then you end up with a six-figure bill for a query that then your boss comes in and yells at you about. So there's just like all kinds of there's all kinds of complexity around it. So what we do at DBT is we have created DBT, which is a popular framework for doing the data transformation, as well as then additionally things like orchestrating your data, being able to discover your data assets, all those things. And so my job as our head of developer experience, and I was joking with Simon before this that half joking that I'm considering changing my title to head of agent experience, is making sure the tools that we are building. So we are building both kind of like a programming language interface and then also tooling on top of that. We're making sure that it serves the needs of the people that are building our product. So that is that's everything from actually going and helping kind of like sketch out here's the direction that we think that data engineers, analytics engineers need to be moving in the future to be productive, to then going working on some of our open source and source available repositories, going and hearing from our users what they need, and just making sure that we are building the things that allow people to actually take all of their data and then make it kind of useful, accessible, all that goes that good things. And that it's fun and interesting to do the work while you're doing that.
Now, you mentioned data engineer there, and I think most of our listeners have probably worked with a data engineer or a number of data engineers in the past. But I feel sometimes like it's one of those kind of roles that maybe can change a little bit between org to org. What's your definition of a data engineer?
Yeah, it's such a good question. I think like with a lot of roles in the data space, particularly like at different organizations or in different industries, you can see kind of like wildly different definitions. But like we think of the data engineers as kind of the people that are responsible for building and maintaining your data pipeline. So you're moving around large amounts of data. You're making sure that all of your that all of your databases are set up correctly. That you have the right kind of like permissions and infrastructure in place. That you could be dealing with business logic and kind of like making sure working with stakeholders to be like, okay, we want this data set defined, or you could be like working kind of in the closer to the middle, focusing on your orchestration, making sure your jobs are run, making sure your tests are passed, and kind of building out your data platform. So it's really, we think of it as like, it's much more of a spectrum than it is kind of like hard definitions, but there is kind of like closer to the hard technology of the databases and like working on underlying database infrastructure, and then there's closer to something like a data analyst or a business stakeholder, and then there's all this room in between. So data engineer is someone that fits in the edge of this, where you're primarily working on building and maintaining data pipelines, making sure that you are building the data sets that are required by your business. And
how do people? I was going to say, how do people kind of get into that role? Do you see people moving from an engineering role, software engineering role into that? Is it people who come from a data background from education and these types of things into that role? What's the typical route?
Yeah, it's a great question. I'd say there's two primary ins. And so the first is, someone will move over from software engineering. You're a software engineer and you find that you are working with a lot of data. You think it's fun and interesting. And so you start to develop a specialty there. And then at some point you kind of like formally make the jump over to software engineer. And then the other one would be you're someone that works in a more kind of data analysis, analytics engineering role. And then you keep shifting left, we call it, where shifting left is kind of like moving more into data engineering. So there's like a good, and increasingly we see people kind of directly targeting data engineering as a career path. So there's data engineering boot camps for people that they're trying to get into it. But the two main ones are to not put too fine a point of it, either you come in from the data route or you come in from the engineering route, and then you wind up kind of in the middle there.
Yeah, cool. Well, let's dip into AI now a little bit. We've talked a little bit about some of the typical things a data engineer will need to do. How much, I guess, in terms of the core aspects that you feel are best for AI to actually come in, help with from an automation point of view, or dealing with large amounts of data or queries. What do you feel like the biggest, like the lowest hanging fruit, the biggest wins that we can make using AI in this space?
Yeah, I mean, it's such a great question, and really, the interesting thing about data engineering is often like everything from software engineering applies, and then there's kind of like slight tweaks that make it different. So everything that your previous guests have said about how AI is going to affect software engineering, that is all relevant to data engineers, because at the end of the day, data engineers are working in ID, they're writing code, that they're doing things like that. So all the things around AI assisted software development, Copilot. I've been just spending a tremendous amount of time with Claude Code recently, and just like really enjoying it. But the difference is when I'm going and I'm writing a web app in using kind of like AI assisted code gen, it all lives in the web app, right? Like we have developed a lot of infrastructure so that I can like create an app and it kind of like lives here. When an organization is working with terabytes, petabytes of data, there's a lot more considerations that have to go into it, because you want to create a script to update an existing query, but then you're going to need to know about all of the metadata for that, all of the history, all of the state. So some of the considerations that I'm sure have to go into development and deployment of complicated software engineering, you kind of like have to get into that from the beginning if you're going to be doing AI assisted data engineering work. So the first input is the low-hanging fruit is exactly the same thing it is for everything else. So we launched a Copilot, and the Copilot is pretty similar to other Copilots, with the distinction that it brings in kind of metadata from your DBT project, and it knows about DBT. So one of the things that people have to do all the time in DBT is write descriptions and tests for their data. And so, it's a lot of boilerplate Jinja. It's not anyone's necessarily favorite thing to do, but very important for having a good, well-maintained DBT project. And so that's the type of thing where as of, coming into this year, we were shaving off the common, cognitively demanding, but not necessarily incredibly complex use cases, just shaving those off, and then putting those into the AI assisted development flywheel. And now, with the current generation of models, it's looking a lot more like, okay, we can kind of create a DBT model from scratch, and it's pretty good, but it still needs to know kind of what the columns are in your DBT project. If it
the LLMs are really probably quite good at building descriptions, but I'd love to know how, when we're thinking about tests for data, what does it, how does it know what the most important parts are to test? And there's a bunch of columns. What data is the most important data? What are the kind of rules that the LLM needs to understand and recognize to actually be able to test this data well?
Yeah, great question. Okay, so this is where you get into the domain expertise blending with the engineering aspect of this. And so the first line of testing that you want to add to a DBT project that you can kind of get that for free. You're doing a lot of testing to make sure you don't have duplicates in your primary keys, or that an entry that's a required field isn't missing. But then when you
hygiene style testing,
exactly, and it's great at that. And honestly, if doing that is a huge game for most organizations. But then things like adding unit tests and making sure that your unit testing the right thing. That is one where LLMs are very smart, and they're very good at being like, okay, this is the type of things that you might want to unit test, but everyone's data is super weird. And most of the things that are super weird about that live in the heads of the people that have been burned by it a billion times. So, doing a workflow where you're where you sketch it out. And I think that's where we are today, where it's okay, it's not good. It will be able to get you a very good first pass of the data hygiene things. And you want to take it over, but it's going to be really good at that. And then the things that are okay, where are the wordy parts that are specific about my business? It's not going to be able to do those just straight out of the box. But what it will be able to do is work with you to, if you describe a unit test, it will scaffold it out. And then particularly if it has good context about kind of what the underlying columns are, what the data types are, what's expected, it really is helpful to have all of that. And then it drains all of that, and then you go kind of validate it and make sure it works. So it's hygiene, it's very good at doing that out of the box. And then the more specific bespoke ones, that's one where you're kind of going to want to work with it to make sure that gets in there.
Yeah, and it almost feels like as well, sometimes these AI is so good at doing things that we are often as humans a little bit lazy to do, or lazy at sometimes. I don't know, whether it is tests or docs or those types of things, AI just isn't as lazy there, and it will go off and it will start documenting everything you want it to document. So when we talk about things like data, do you find it sometimes being more complete than if a human were to do it? Are there areas that you feel AI is actually more competent almost at completing than if a human were to do it?
Simon, it's so great. Okay, so first of all, so first of all of our users are perfect, and they always document and test exactly the same shit. I'm lazy.
I think we have the same users.
But but I'm lazy, and so I will be writing. It'll be like, oh, I'll fill this in later. I'll have the testing later. And so for me personally, I have found that, like, particularly if you're the type of person that, like, you're kind of sketching out the 15 things you want to do, and you want to like toil through all of them, and then you leave yourself a bunch of like, oh, I should do this. Like that's just the kind of workflow that's just like, it feels. I mean, like, I know we've all become like a little inured to this. We're like 2 or 3 years past, but it feels like magic. It feels like something I never thought I'd have.
Yeah. Well, first of all, excellent cover, Jason. That was brilliant cover for your users. Secondly, in terms of the various things, Copilot, that type of action that AI helps with, descriptions, tests for data. What else will AI help with for data engineers these days?
Yeah, I mean, so we think it's going to be helpful ultimately across the entire stack. So going and writing your data models, refactoring your data models, debugging a data pipeline breaks. Okay, why did this break? What do I need to do? What needs to change? The thing that's missing from that right now is not really model intelligence. Models are pretty much good at doing all of this today. The problem is kind of like building the scaffolding to get that data to them and productizing it. Because like if your model breaks today, there's like a relatively like, you can take a first set of things like, okay, like why, like look at the logs, and of course, like when anyone's pipeline breaks today, what's the first thing that they're doing? They're taking it, they're pasting it into one of these things. Anyway, so it's building the system such that the first layer of problems across all of this, and the first pass of any of this should be able to be addressable by the LLM. And so I'm really hopeful we will get to the place where it's like, okay, everyone's data systems work better. You are able to build more data products cheaper and faster, and with kind of like less just toil in terms of making it and maintaining it. And that to me is kind of like that's like baseline. That's like the minimum thing that we're going to get. The thing that then gets, I think, more interesting is, okay, but then like, how is all of that stuff actually like much more useful in a world where it can then be connected into other AI applications?
Yeah, no, very interesting. Let's jump into one thing that I think is really important there, which is when you have huge amounts of data, and you want the LLM to kind of like, if you, based on a query or prompt that I give it, how do you get that context window right to get the best results back?
Yeah, it's a great question. So if everyone in the DBT universe, in the data engineering universe, we think in DAGs, right? Directed acyclic graph. And so we actually have a lot of information about your DAG, about the models and about the columns and all of that. Obviously you can't pass all of the data in a system, but even for these big organizations, you can't pass all the tables on the screen. They have thousands of columns and descriptions and all of that. So we think of modularity has been like one of the key concepts of how DBT has transformed data work to begin with. It used to be, a decade ago before DBT, you would be working and you'd have these 5,000 line SQL scripts, and they would be maintained by a couple people, and those people, their entire life would be like debugging this one SQL script. And we're like, all right, well, what if we broke that up into models and you like ran them bit by bit, and then like when one breaks, you can like see downstream. So there's a lot of concepts and abstractions that. Not just DBT. This has been happening across the data engineering world, but data engineers have been working on how do we create the kind of modular concepts that then a human can work with. And actually, I don't know about you, Simon, but my personal context window is actually a lot smaller than 200,000 tokens. So we're actually able to get a lot of additional context into these for generation. It's based off of DAG information.
And as part of that, when like presumably you're using AI here to generate a lot of the queries, a lot of the SQL and things like that. If you're using AI in that way, how do you deal with things like security, things like, obviously when you're gathering that kind of data, that you're not at any time injecting bad things or those types of problems?
Yeah, it's a really really good question. So typically in the data engineering world, like we are less dealing with kind of like SQL injections or anything like that, because typically the people running these are people that work for your company. But the thing that you still need to think about is, okay, how do we make sure no data is getting exposed either internally or externally to people that shouldn't have access to it? And this is one where it's leaning on familiar abstractions and the ways that we have been building out governance kind of as an industry. Those same things, I feel like I'm kind of repeating myself, but it's a really important concept, which is like the set of abstractions that we built to solve hard problems for humans are going to be the same set of abstractions which you're going to need to use, but then build upon for AI systems. So it's like if you have an AI system agent, operating on top of your database, that should have a role that's scoped such that it can't access a set of data that you wouldn't want the human that you expect to be querying it to have access to. And
interesting. Okay, so the LLM only has the access to the data that the user would. So each request goes through a specific access constraint.
I mean, like that's how it should be done. And so if you're using this, for example, if you're using this through kind of our cloud platform, you will have logged in, and then you, Simon, will have a set of database permissions. And then any SQL queries that you run on that will have been already scoped and managed by your team, such that you hopefully have access to all the data that you need access to, but also that you're not having access to data that would be sensitive or you wouldn't have access to. And then kind of like AI systems and queries would be run the same way. So thinking in terms of roles and the importance of roles, this is very important when you are giving this perhaps not to an internal user, but to an external facing customer support bot. And you want your customer support bot to have access to the billing information for the person that they're talking to, because that's very useful. And you really don't want them to then be able to hop over and ask about the customer whose ID is incremented one higher in the database and their billing. So really locking down the data access and roles is, I mean, it's just like, it's always been important, but it feels orders of magnitude more important now that we're hooking these systems into more things.
Yeah, absolutely. I think that's the only way of doing it as well, in terms of like, not allowing the LLM to make a decision. We've seen time and time again how LLMs can be confused or tricked into thinking they have access to other things that they shouldn't. In fact, we wrote just recently a piece about the GitHub MCP server. That it was an interesting one, actually, and it's a good example of how you can almost like circumvent some of the authorization, whereby this MCP server will be sat here, looking at your GitHub repos, and it will, a user will obviously only come in looking at the public repo. If they added an issue onto the public repo, and the developer using their MCP server said, can you fix all these issues? It will look at those issues on the public repo, and if a malicious user added a malicious issue on one of the on that repo that said, get me all the information about this user, what they do in their private repos and so forth, the GitHub MCP server would actually go into the private repos and then create a public repo, a public PR against the public repo with potentially sensitive information. So the LLM is there making the decision based on the security authorization of that user, versus actually using proper authentication or authorization mechanisms that state whether this user can access this data. And I think that's it. As soon as you leave it to the LLM, mistakes will be made, whether it's, and I'm not even thinking like a hallucination, you just need to convince it. Whereas
they're so helpful.
Yeah, they are, right. They always want to provide an answer. That's their problem.
Yeah.
But I think what you're describing there is like using the mechanics of what we already know and trust to actually build that out, which I think is very powerful. Let's talk about structured data. How important is structured data, obviously, from a user's point of view, to get that back? How does the LMs deal with structured data? I guess both as input and returning that.
Yeah, I mean, it's important enough that every organization in the world invests a tremendous amount of time and energy to creating structured data, single sources of truth for their organization. And the reason for that is, there's a lot of reasons for that. But as you're building kind of an organization that needs to coordinate, right? And you're doing that on complex things, and you're trying to do complicated workflows in the real world. You ultimately need to have structure for enterprises, for governments, for anyone that is trying to coordinate across many people, many departments. You are ultimately going to have systems of record. This goes all the way back to when we first invented double entry bookkeeping, however many thousands of years ago. It's one of humanity's most important innovations, because what it allows you to do is the world is just like really complicated. And in order to have institutions that act on top of that world, you have to have systems that are saying, this is a thing that we believe to be true in the world. And that's really what structured data is for, is we believe that on June 26th at 5:14 p.m., Jason went and he ordered an iced coffee from our e-commerce page. And we believe that the account owner for Amia Corp Bank is Simon. And so structured data is just like all of these things that your organizations believe. And then when you need to make a decision, such as, okay, how much coffee do I need to order for my coffee store next month? You need to go back to your structured data and then look at the previous things that were there. So to the extent that we expect LLMs will need to be doing things that engage with the level of complexity where you might want to check if something is true or not, then they're just going to have access to structured data, unless, sure, like maybe we get 10 trillion context window and they can just do it all perfectly in context. But in a world where that's not happening, then they're just going to need to act on top of data and on top of structured data.
Yeah. And in terms of what LLMs are bad at in this respect, what would you say are the biggest problems that you've seen using AI, dealing with data, dealing with building these kind of like these various queries, requests for data? What would you say it's not particularly good at, that in years to come it could perhaps have scope to grow in?
Yeah. So one thing it's not particularly good at right now is coming back with the same answer every time, even if that answer is technically reasonable or right. And this kind of goes back to your GitHub example. So it's like, what one of the things that we say kind of ad nauseum is like, every organization defines revenue differently. And in fact, every organization probably has 5 or 9 different definitions of revenue that ultimately some poor soul has to go and reconcile them and be like, no, this is like the one true definition of revenue. LLMs are like a very like smart, eager, but they don't know anything about your business. So it's like, you tell it to go calculate revenue, it's going to like come up with 1 of 9, or it's going to make a 10th, an 11th, a 12th. So it's really good at writing a SQL query that looks reasonable, that like produces you an output. But if you are trying to like bake these things into your critical business systems, you're trying to do things even where like one of the things data is most helpful for is having people like, I look at something and I develop like a mental model of the world, and then you look at it and you actually develop the same mental model of the world, and then we can kind of collaborate and coordinate across that. And LLMs are just not good at that right now, because they just don't have enough context. They don't have the system of record to create the single source of truth right now. So that thing is actually like really interesting and really important for deploying and scaling AI systems and making them actually kind of useful organizationally.
Yeah, and I guess like using that example that you just provided, let's take revenue as a great example, right? If you have a COO or a CEO or a CTO or someone who's caring a lot about these very specific numbers, and it's really, really important they get accurate numbers, and they ask for something, they ask for it a day later, and it gives them a different answer through either non-determinism or perhaps they've asked for it in a slightly different way, in a very subtly different way, but it gives them a different answer. How important is it that these types of things are deterministic versus actually requiring some level of validation before on pretty much everything it provides you with at that level?
Yeah, it's a good question, and for things like what you were describing, for CEO level reporting or things where you're going to be making kind of like hard business decisions based off of them, or board reporting, or you have a duty to report something accurately to the board or something like that, you got to give like the exact right answer. And so this is one of the things that we have what's called the semantic layer that sits on top of your DBT project. Is that defines the semantics of your business. So you would define something called revenue, and then you would say, for us, revenue means this column aggregated by these dimensions and these times. And one of the other things that LLMs aren't as great on is kind of like thinking in like the rectangles that are their structured data tables. They're actually much better in thinking in terms of the semantic concepts as defined in the semantic layer. So if you give them semantic concepts to map onto, it's a way that LLMs can actually reason about this that fits in with how they reason. And so we ran some benchmarking on this. It's just much, much more accurate if you do the same set of natural language questions on top of your semantics as on top of your structured data. So that's been really interesting and useful finding, and one that I think folks across the ecosystem are seeing.
Yeah, and that makes a ton of sense as well, to kind of like give it that advice or that path that it can follow. I guess, are hallucinations a big problem here? I guess it probably, you need to give it a request where you don't have those semantics, where you don't provide it with a good path to go down to understand where to get data or how to format data. Is that something that can happen that much?
Yeah, so I mean, hallucinations happen. They happen across the board in any LLM workflow. We find that most of the time, what's going to happen if you're getting hallucinations is you are hallucinating a table name or a column name or a database function that doesn't exist. So actually, like, your query breaks. And so honestly, you'd probably rather have your query break than have it do something that's not a hallucination, but it's like not quite right. Like, not quite right query is actually much worse than like a query that just breaks. And so like the hallucination not solved, but largely addressed when you present it the right set of context. So if you present it enough DAG information, and right now we can only do this like for certain projects at certain scales in certain ways, but ultimately, like, this is going to, like, we are going to solve the problem where it's like, when you want to write a SQL query, like, you're going to have a good information of like, here is the here's the dialect here that you have, here's the functions that you have available to you, here, like, here's the columns that you have available to you and their data types and all that stuff. And then so you'll be able to do something. And then it's okay, but is it exactly right? And that's where then you need kind of the semantic mapping and all of those things on top of it.
Yeah, and it's nice in that sense, because there's a level of abstraction between the LLM and the actual result that you get back, right? It's almost like I guess if there's going to be a hallucination on code that gets created, the chances are it's going to break. It's going to break in compilation, or it's going to break when it tries to link to something that doesn't exist, or try and hit an API that just plain won't work, rather than the worst case scenario is it hallucinates quietly and it provides you with something that's incorrect but won't provide you any exception at all. So there's this nice layer of abstraction there where chances are something will go wrong if it hallucinates. In terms of human validation, I guess in some of the workflows that you've seen across DBT and others, how much human validation is still needed maybe even across the queries that are created, how much can be automated in terms of validation versus that human in stop the world and check before you actually run these things?
Yeah, so I'm of the belief that where we are right now is, if I'm sending you something that was generated by an LLM, I'm signing my name to it, and I need to have validated, right? And so it's ultimately it's on the person who owns the workflow to know, okay, this is the set of things where it's going to be like, it's going to be fine, versus this is the set of things, which at this point is most of the things where it's like, it generates code, okay, and then I go through, I read through it, I make sure it's right, I might tweak something, I might check, perhaps my understanding on something was wrong, but like, I right now we're at this interesting thing where it's like, we have this higher level programming plus, right? And like, you can operate on that level, but it's like, it's there enough for when I'm building a side project, which is like an MCP server that lets you like world build like a fantasy or sci-fi world from scratch, and like that's all Claude. I look at the code, I'm like, yep, okay, looks good. But that's because that's just for me. If I'm signing my name to something, I'm reading through the code, I'm vetting it, I'm validating it, I'm checking, make sure it works, and that's what I'd recommend for people today. But look, things move fast. 4 months ago, you couldn't you couldn't rely on these systems as much as you do today.
Yeah, and let's talk about MCP servers, because this is a really nice way now of actually being able to get to your data now, right? Because I presumably with a MCP client attached can ask a question. All of a sudden, the LLM will magically hit this MCP server, perhaps that you provide, and then all of a sudden it's grabbing data for me, it's pulling dashboards and presenting things to me. Do you see this as like one of the core ways people can access data going forward? And I guess how mainstream is this in what you're seeing today versus things that we've talked about already?
Yeah, so I'm just so excited about MCP. It feels like it blew the lid wide off. So I had a habit, but basically from the week after ChatGPT launched onwards, where I would go to LLM provider of choice and I would type in what is my revenue, and it would say, I'm sorry, I can't answer that because I don't have information. And then I would post it on Slack, and I'd be like, the only thing that matters is if we help people answer this question. And so for however many weeks, too many weeks in a row, but that was the answer. But then when as MCP started to pick up steam, it's like, oh, we now have the way that we can provide this to people, because like it's so useful to have access to this data. So we built the DBT MCP server, and now today I go and I log into any MCP enabled client and I type in what is my revenue. It goes, it looks at my semantic layer and it says, I see the revenue metric. I'm gonna calculate that. It says your revenue was at X amount of dollars, and honestly, like this pretty quickly became my primary way of interacting with data. But like I'm like perhaps not your normal data consumer. How mainstream is this? Forward-looking data teams are adopting it as prototypes and pilots and rolling it out kind of on that basis. Everyone's thinking about it. Everyone's experimenting with it. And there's just no real question that this is going to be how people interact with data moving forward. It's just so painful to go and like scroll through every like thing that you might have available to you, and you just don't have to do it anymore. You can just go in and say, what was my revenue? And there's going to be a lot of work to make this enterprise ready and make it all of the things that we need. But the writing is on the wall. It's so hard to imagine this not happening, just because it's such an incredible increase in ability to access data.
And we talk about kind of like developer experience, and let's talk about user experience, because I feel like one of the things here is, if this kind of thing was made available with an organization, and all of a sudden you get huge amounts of data that are fronted by these MCP servers that anyone can now access, you're going to get a ton of people way more interested in accessing data that they before didn't know who to talk to or how to get this access to the data. With this, I'm presuming going to be massively increased usage of or massively increased demand for access to for just generating requests to this data. Where does what's the bottleneck now? Because is there going to be now a big bottleneck in terms of, are we getting all the right data in? Are we formatting the data correctly now to actually get all these new use cases that we perhaps didn't have before because it wasn't so readily available? What do you see as the new bottleneck?
Yeah, I mean, I'm so glad you asked that question. And this almost gets us back to the very first thing we discussed when we're like, what's the data engineer of the future doing? They are building out the set of use cases now. So it's like, okay, like data is both going to be much easier to access. It's going to be much more important that it's correct because more people are going to have access to it. And, maybe we'll get to this. Maybe you'll be driving agent workflows on top of it. So the fundamentals of this are still going to be important, right? And the fundamentals are still, very challenging to take in all of your data, to make sure it's accurate, to make sure that the system is kind of well honed. And so that's half of it. And so that's like what the data engineer of the future is going to do is they are going to be creating the set of data that then MCP or things like MCP will sit on top of, and then people will query it and they'll do that. And then what's a little more fuzzy is what you would call them, I don't know, data analyst of the future does and how they fit in. Because traditionally we're always going to have dashboards. We're still going to do dashboards, but like I've always thought it's kind of crazy that we put so much effort into like learning about the world and learning about ground truth, and then like building up these things, and then it's like, okay, and we have like this set of bar charts that we look at, and the bar charts are great. Don't get me wrong, I love the bar charts, and they're additional things. But now, like, we can actually use this kind of as like the central mind for then LLM processes to go and take actions off of, and that's a whole new industry. That's a whole new thing.
Yeah, and actually evolving dashboards based on the data could be super interesting. Like as things start going south, well, let's deep dive into those and actually pull more data in that, so that actually we have almost like these monthlies or quarterlies based on the painful areas versus just this standard traffic light style dashboard. Sounds amazing. And so you see the data engineer then much earlier in the cycle versus later then, presumably. So it's more about that quality of data, the structure of the data, the quality that kind of goes in. Is that fair?
I think that's right. So your MCP or the system like MCP is gonna sit on top of your data platform of choice, or your iceberg tables or whatever, and then it's going to have access. It's going to need to have access to just a tremendous amount of well-modeled, accurate, well-governed data, and so that's what the data engineering will be doing. They will be orchestrating that, testing that, making sure that it's all ready for then whatever kind of set. This is like a bit too too simple of a heuristic, but they're doing everything pre-MCP, right? And then there's like another set of things which is like post MCP, or data engineers and analytics engineers, and analytics engineer being the ones that still also focus on building out the data object, but they're much more in the weeds, kind of with the domain experts, with the business context, and making sure that because the MCP, it doesn't just need tables that are like technically built well, it also needs tables that have like deep context and understanding of the business, right? And they're built in such a way that they are the correct layer of abstractions and the correct descriptions and all of that then they can go and like take actual useful action based off of.
Yeah. And one other thing, actually, just before we kind of wrap, I'm thinking about this data engineer, this future data engineer role. And if we compare it to a data engineer pre-AI, what data engineer would need to add into their kind of like their databases, the style of the the types of data that I need to add in. How would they know about that? Well, it would typically be because they would get certain amounts of requests in and a certain amount of probably the business knowledge and the local knowledge that they had. But now with the explosion of something like an MCP server, you can almost like see a lot of the requests that are kind of like, I guess being asked for on potentially even. Is it more of a demand thing then? I'm trying to think, who does that data engineer need to talk to in order to do the best job? Is there a possible future here whereby, based on the number of commands that are kind of like coming in, whereby people are asking for these types of things, that the data engineer thinks, okay, I need these types of data in order to be able to satisfy these requests? Feels like, I don't want to say the data engineer role is getting lonelier and lonelier in terms of who they're going to be interacting with, but I guess how does that data engineer interact to get that level of input?
Oh, what, man, that's so fascinating. I'm imagining, we're gonna have well, the metadata is one of our favorite. We're going to have the metadata of, all of the requests that come in that hit the MCP server. And it'll be, one of the things we'll be able to do is be able to say, like, were we able to answer this question, or does it rely on data that we don't currently have access to? And then, it's like, it'll be not knock on wood here. Everyone's gonna yell at me for saying this. Relatively trivial then to like build out like reporting on top of that. That's like, oh, actually, like a ton of people are asking about like this data source. Like we're seeing all these requests come in. It's of our requests per day, 17% aren't able to be answered, and 41% of the 17% that can't be answered right now could actually be addressed if we bring in like this additional data source. Right. And also, like, here's where you can find that data. So yeah, I mean that's a very great question, really interesting concept you guys showed.
Because I think it's interesting because a lot of those questions wouldn't have been asked previously, because a lot of those people wouldn't have necessarily gone to someone to ask for that. So it's quite interesting to see how this is almost the enablement of this user request mechanism through just lateral language in an MCP server is potentially even actually seeding what data actually then gets added in as well. So it's a kind of like a nice full circle, really.
Gotta get the data flywheel moving.
There we go. We've named it. Wonderful. Jason, this has been a blast. Look, geez, we're almost 50 minutes already as well. Jason, this has been a blast. I hope everyone online has enjoyed listening as well. Thank you very much, Jason. Where should people go to check out DBT and to learn more?
Yeah, so if you head on over to getdbt.com, you will see all about DBT. We recently launched the DBT Fusion engine, which is a ground-up rewrite of the DBT engine from scratch. It's 30 times faster parsing speed. It has very good type awareness and SQL understanding. So a lot of the things that are going to actually allow you to build in the deep DAG awareness and the deep context that's built into the new engine. Suggest you try it out. Please find me on LinkedIn, Jason Ganz. We have a community Slack for DBT, so you can shoot me a message there. You can find me on the website formerly known as Twitter. So just wherever we'd love to stay in touch with folks. And Simon, this was a blast. Great talking to you. You have a great audience. So yeah, it's really fun to be here.
Amazing. And Jason, it'll always be known as Twitter for me. I don't know about you.
Yeah, that's right.
Yeah. Thank you very much. And to all our listeners, really appreciate you listening. Hope you enjoyed it. Tune into the next episode, and all of those links that Jason mentioned, we'll add them into the show notes as well. So do check them out. Thanks all. See you on the next episode.